The second question, it gives us a joint density function of x and y, and it gives us the range of x, y, which is a circle, and the question A asks us to find B so that fxy is a valid joint probability density function. So in order to so if this is a valid joint density function, the integration of this function should equals to 1. So we do the integration on this function on both x and y, and we also have a trick to convert the x and y to the radix to the r and the theta, and we will give the we will find the result and let it to be 1, and therefore b should be 1 over pi. And the problem B, it asks us to calculate expectation of x under condition of y, x, y. There's so much expectations. So for the first, for expectation of x, we need to do the integral over x times fxy, and we can see here that we can change the reformat this equation and turn to this, and we can find that the integral here is 1, and the range of y is bounded by a circle, and we continue to do this integration. We'll get the result of x times square root of 1 minus x squared, and we can see that x times square root of 1 minus x squared is an odd function, and the range is from negative 1 to 1. Therefore, the integration of this value is 0. So the expectation of x is 0, and for expectation of x in terms of y, and we also do the integration f times fx in terms of y, and we use Bayes' law to transform it the conditional probability density function into this form, and we continue to do the integration on fy, and the range of x is actually bounded by the circle, and we can calculate the result of this value, and same as the previous one, and this result is also be 0. And for the third, the y becomes a capital Y, and so that means for every individual y, the set of y is also applies the same rule. So the expectation of x in terms of capital Y is also 0, which is the same as the previous one. And for the fourth, for these three, we know that since x and y are symmetric, therefore these three expectations are all zero. And for the expectation of x times y, we also do the integration um, using x and y, and we can see the range is bounded by a circle, and we can get to this result. And since y is an odd function, and we can get the expectation of x and y is zero. And the problem C asks us to find out whether x and y are correlated or not. And from the question number 2, we know that we have calculated the expectation of x and y, and also the expectation of x and expectation of y. We know that the expectation of x and y equals to the expectation of x times expectation of y, and that satisfies that the x and y are uncorrelated.